Alright guys, in this video we're going to be going over the PowerProbe. And more specifically, we're going to be going over the PowerProbe 3. So your tool number is right here, and you guys can search for that on the internet. I'll be putting a link down in the description for anybody who wants to go check it out also. So the first thing that we're going to do is actually open it up and see what it comes with. This is my model, it is used, but it's still very functional. So first thing we're going to do is open it up. Alright, so let's get started. So in the box we have the main unit, which is the PowerProbe. Okay, the PowerProbe comes with a length of 20-foot wire pre-attached to it. On top of that, it also comes with a secondary wire, which is also 20 feet long. So you have a total of 40 feet of wire. So you can work on either small cars or even semis and have way more than enough. After that, we have a cigarette lighter connection to get 12 volts while you're inside the vehicle. Then we have your main connection, which hooks up to your battery positive, battery negative. And then we have the probe tip. Now without this, you can't really use the PowerProbe. Well, you can, but if I'm not mistaken, you could take a 4mm banana jack and stick it in and you would be able to use it also. So that is what comes into the box. Now we're going to go over some main features of the tool. So this is where your PowerProbe tip goes in. Then you have two bright LEDs right here to illuminate your space that you're working on. You also have, let's see if I can get in a little closer. You also have a positive and negative LED. The positive will light up red, the negative will light up green. Then you have a rocker switch to either add a positive or a negative polarity to the component that you are testing. And then you also have a volume button, which is also your mode switch. And after that, you have a circuit breaker on the side. Now the circuit breaker will trip if you get, let's just say you're onto a ground circuit and you are add power to it, well, the circuit breaker will trip. And if I'm not mistaken, it takes 10 seconds roughly for the circuit breaker to reset, and then you are able to push it back in. So those are the key features of the tool along with its components that it comes with. Now we are going to get into using this tool for testing. Pull out some wiring. I'm going to hook it up to my battery. So, and also, there is no way to mix up the polarity. It is one way fits only. So, now we are going to take and hook up the red to positive. We're going to take the black, we are going to hook that up to negative. And that tells you that your tool is working. Now, as I told you, there are two LEDs on the top for illuminating the space that you were working on. After that, I also told you that you had a positive and a negative. And when you hit your positive, it lights up red and it shows you your battery voltage. And when you hit the down onto the toggle, it will light up green and it should show you your ground, which is 0 volts. Now, there is one step that I always do, is that I always take my, oh, I actually forgot that. The PowerProbe also comes with a constant ground. So this alligator clip is connected directly to the negative terminal of the battery. So I always I put it on and I add 12 volts. And as you can see, my toggle, my circuit breaker just tripped, which tells me that my tool is in good working order. Now it's been about 5 seconds, and I can take it and I can push it back in. So whenever you're using the PowerProbe and you're trying to test a circuit, I strongly advise that you make sure that that circuit is turned on. Now, the only reason I say that is because if you have a simple circuit, as I do right here, where you just have a positive, and then you have onto your component, and then you have a positive, a fuse, a switch, your load, and your return path, which is your ground. If you only have this type of simple circuit, what is going to happen is that if I come over here, you will see that I will have 12 volts. If I come over here, you will see that I have 12 volts. If I come over here, you will see that now I am on ground. But I am on the positive side. Now, why is that? Well, because don't forget, inside this motor is just a plain coil wire. So basically my ground is coming all the way through, going through my coil, coming all the way up my positive lead and hitting on this side. And that is because my circuit is not turned on. So it doesn't matter if I would test over here, I would get ground. I test over here, I would get ground. And if I test over here, for sure, I will get ground. So whenever you're testing a circuit, always make sure that your circuit is turned on whenever using the PowerProbe. It will just let you know that your circuit is actually intact 100%. So I'm going to turn it on. And now, as you can tell, I got 12 volts. Over here I have 12 volts. Well, battery voltage over here. Now I have battery voltage. Over here I have battery voltage. And over here, now I have my ground. And my circuit is complete. So I went through all that, seeing that my circuit was complete all the way through. Now don't forget that because I am connected with the PowerProbe directly to the battery and I am testing at different points, it is also checking the voltage drop of that circuit at the same time. Okay, so if I come here, you guys would see that I have 11.8. If I come here, I have 11.8. I have 11.8. I have my ground because my circuit's turned off. Okay, and then if I come over here, I have 11.7. Voltage is going down. Then ground and ground. So as you can see, there was no voltage lost along that. Now I'm going to take and I'm going to create a voltage drop onto the system by using a resistor. Okay? And we're going to see what happens. Now, as you can tell right now, I am connected to a resistor. Now the resistor that I am using for this test is 523 ohms. Okay? So now, let's do that same test. Now this is going to be checking a voltage drop for you guys. So what we are going to do is, like I said, it's always best to make sure that your circuit is turned on whenever using the PowerProbe in order to test your powers and grounds. That way you're able to see if there is an actual voltage drop somewhere along your complete circuit. So what we're going to turn it on. We're going to touch here. And as you can see, with my switch turned on now, my motor is not working. So we're going to touch here. I have 11 volts. If I come up here, I have 0 volts. So let's just say if this was a corroded terminal onto your battery and that was your starter motor. Well, if you come to your battery, you would see 11.8 volts, which is normal. You should see 11.8 volts. But then when you touch your terminal, well, you have a major voltage drop. You're not seeing any voltage whatsoever. So that would indicate that you have an issue between your battery terminal and your battery post. Your battery post to your battery terminal. And as you can tell, it is like that along the whole entire circuit. So that is a quick way to use the PowerProbe as a voltage drop tool. As you can tell, if I had a smaller resistance, I would, actually I might be able to for you guys. I'm going to pause you guys and I'm going to set something up and we'll see if it works out a little bit better for you guys. So unfortunately I wasn't able to find anything in order to be of a lower resistance value. Sorry about that. It would have been nice to show you guys that at the same time. But we are going to go through some more key features with the PowerProbe now. So we went through how to hook up your PowerProbe to the system and how to do a quick voltage drop check across your circuit with the PowerProbe. So the next step we are going to be doing is checking for continuity with the PowerProbe. Now this can be done mainly with a switch. Okay, and it can also check for continuity with a resistance that is lower than 2000 ohms, and it will also check a resistance that is greater than 2000 ohms but less than 20,000 ohms. So in order to do this test, we need the ground alligator clip of the PowerProbe, and we need the PowerProbe tip. What I am going to be using is just my light bulb. Okay, so this is basically testing a component for a continuity check, and it's very, very quick. So the first thing that we're going to note is, remember what I said, that under 2000 ohms. Now what happens under 2000 ohms of resistance? Well, we're going to take and we're going to hook up the ground lead from the PowerProbe to the ground side of, let's just call it my switch for this purpose, and we're going to take the power and we're going to put it onto the tip. Now if you were testing this, you would be testing it onto your terminals of the component itself. So as you can see right now, with an open, nothing happens. So basically think of this as a cut wire onto your car. So we have an open here, and as you can see, there's nothing onto my LCD screen and well, my digital screen, and neither lights are lit up. Now what happens if there is continuity, but that continuity is under 2000 ohms? I'm just going to put my light bulb back in, and as you can tell, my ground LED lights up. Now what does this indicate? This indicates that you do have a continuity into that circuit, and that continuity is under 2000 ohms. Now what happens if you have continuity that is greater than 2000 ohms? Well, I have a resistors right here, and the resistors are 11.8 ohms. We're going to take and remove one, and we are going to be doing the exact same test, but this time with a resistance that is over 2000 ohms. And I'm just going to touch on this one, and as you can see, we have an LED, no LEDs that are on to indicate ground or power, and we have two zeros. We have two zeros onto our voltage. Now that indicates continuity over 2000 ohms. Basically, think of this as an excessive resistance into a circuit. So if you would have excessive resistance into a circuit, well, you're testing continuity with your PowerProbe, it'll give you an indication that you have a resistance of over 2000 ohms but under 20k ohms. So over 2000 ohms of resistance, we get no LED. Under 2000 ohms of resistance, we get LED that turns on. Now this is for continuity checking with the PowerProbe. Is it precise to 100%? No, it gives you a pretty vague region, but it can still help you in your diagnostics. So the next part after that is actually powering up a component or activating a component using your PowerProbe. So let's take this light bulb for example. Now if this light bulb was on the car and I was testing to see if my circuit was good, we could take and just power and ground, following your wiring diagram, light it up, and it works. I'll do that over here. Alright, so that's how you would activate a component. Now, there was a few key points to point out in that. Now, as it is powered up like this, remember, it does a continuity check automatically I don't know if you guys noticed that. Remember what I said a while ago. If you guys are checking continuity of a component, it will take and your LED, your negative LED will light up and your screen will be. So as soon as I hook up the tool to a component, it takes and it checks for my my continuity of that circuit, and this one tells me that I have a continuity of under 2000 ohms. Now, some of the other components that you could test also would be like fuel pumps, magnetic clutches, starter solenoids, cooling fans, blower motors, lights, and things like that. So it is very important to remember what this tool is capable of doing. So here I have a motor, has a little bit more amperage that is drawn than the light bulb. And like I said, tests your continuity of your component automatically when it is connected. So I have a continuity of under 2000 ohms. So far, we have gone through continuity test, power and ground checks, voltage drop, and component activation with this tool.